Hello. Very, very delighted to be here at this wonderful conference. And I'm going to be talking about Redis, Postgres, and why at scale the decision on which one of these to use is sometimes not as obvious as you might think. So about me, I have 24 years of experience now with Postgres. I've worked as a database administrator, as an engineer, software engineer. I've built database teams, run high-scale architecture, and stuff like that. So I love Postgres. I love it for its versatility, but this talk's going to be much more about performance and scalability. Want to give a few thanks before I start. Obviously to Timescale, who pays for my time to come here and give these talks. Very, very, very much appreciated there. Also want to thank Just GmbH, where the case study came from and where I got some of the interesting experience in this particular topic. And actually, the delivery hero point there is actually not applicable. I didn't really do much with Redis there. That's a mistake there. Also want to mention OrioleDB. Part of the idea for this talk came out of a personal collaboration I had with the OrioleDB team. And the question of what we can do to make Postgres better in some of the workloads where Redis is there. And they're doing some interesting things with that in terms of like flash optimized storage and things like that. So want to especially thank them for all of the conversations and stuff that have led to this presentation. So agenda, we will talk about databases at scale and how they work differently than they do when we're just starting out. And then we'll go through the case study that I have from Adjust. We will talk about Redis internals and basically the things that constrain Redis in this highly scalable environment. Then we'll do the same for Postgres. And then we'll go through some basic recommendations. So basically, the reason why we're doing this talk is there are a lot of misconceptions. People think, oh, Redis is fast. We're going to use it here because it's faster than Postgres. That's not always the case, okay? It is sometimes, but it's not always the case. This is true both on Postgres and Redis. There are a lot of misconceptions that people have about scalability. Both are good databases. They're both open source. If you have a problem with one, you can read the source code and usually get an answer really fast. But oftentimes, we don't have a lot of guidance as a community on how to build really scalable applications on either one. So this is mostly what we're going to be talking about here. So big thing is database use changes at scale. When we just start out, we have like a small database. We tend to look at it as a black box. We learn how to write SQL queries, things like that. We don't really have to worry about indexes. As things grow, we become more and more wedded to the internals of the database engine, and those things become more critical for performance. So when we get 1 gigabyte, the whole database sits in memory. It doesn't take that long to read and process a gigabyte of RAM, and so we can write inefficient queries. Who cares? It's only a gigabyte of data, right? But when we get to 10 gigabytes, then typically we have to start learning about indexes, that sort of thing, because now not everything's sitting in memory. We have to start thinking about storage, and query efficiency starts to become important. So we go from being a total black box to actually having to think about a few internals. Every time I go up, I'm just adding a 0. There's a reason for that. My experience is every time we go up by 10 times, the kinds of challenges we face change. So by 100 gigabytes, indexes start really mattering. We start having to actually think about storage frequently. Backups aren't things that you can just run a quick PG dump of the database and then quickly restore. And you tend to be getting really into Postgres performance stuff at around this topic, about this size, right? So what happens when we hit a terabyte? Now backups are starting to require specialized knowledge and frameworks. Certain tools that worked before with backups now start not working so well, and it becomes really important to look at these things. We start looking at performance and auto vacuum tuning a lot more at a 1 terabyte database than we do at a smaller database, right? And at a terabyte, maybe you're starting to see some like physical limitations hitting, but you're not typically hitting too many of them, right? So these are just some of the things that typically happen when we hit a terabyte. 10 terabytes, internals start mattering a lot. You start hitting fundamental bottlenecks relatively frequently. And so you end up having to start reasoning your way through things from an internals focused perspective, simply because now you're hitting the limits of what your storage can do. You're hitting the limits of what your processors can do. And typically there aren't any quick fixes anymore because you've already done them all, right? So what we see as a trend here is that early on, our databases are black boxes. We learn how to write queries. We don't really care about performance because it's a small database and nothing we do is going to perform badly. And trying to understand the performance cost of things is really straightforward because there really aren't any. But when we're then working with large scalable applications, these advanced features matter a lot more. And we're typically spending a lot of our time reasoning about things from internals. And there's a big reason why I keep talking about internals here, because a lot of this talk is going to be about some aspects of both Redis and Postgres internals that are important in this field. But when we get really big databases, we typically hit bottlenecks that are implementation dependent rather than dependent on our application, right? Usually it's not that we did something wrong per se, it's just that the way we did something didn't work very well with the database that we were working with. So on to the case study. Now, I want to talk just a little bit about how this architecture came about. When Adjust was started, their first proof of concept was written in Node.js and MongoDB. Then they discovered Node.js didn't scale, and neither did MongoDB. Web scale aside, apparently it's not edtech scale, right? So their second approach was to put all the analytics data into Postgres and their live data into Redis, because Redis is fast, it's simple, we can get rid of these bottlenecks, and that worked for a while, right? But eventually we ended up with a system with like 20 large Redis instances, each one running 20 large Redis servers, each running 10 Redis instances, managed with Sentinel and Nutcracker. So everything sharded and replicated and supposedly highly available, but it's really brittle. It's a nightmare from an administration perspective. And everything here just became something that just ate up a lot of administrative time. It could lead to problems and outages if something fell over. And so eventually they started moving some things off. They moved most of their live data off into another closed source database, Aerospike Enterprise. And then they moved much of the rest of the data eventually into Postgres. So the issue here is, why did you end up with a need for such of a massively complicated, difficult, and costly infrastructure? And what can we do about this? Or what can we learn about this when we're trying to make the decision? So reasons to move. The RAM was really expensive. You have a whole lot of servers, and these were bare metal servers, right? Fairly beefy servers, lots of RAM, and they're mission critical. So something goes down, and Sentinel doesn't fail things over properly. Now you actually have people jumping in because it's an emergency, and we actually had some cases where failover wouldn't get routed to or wouldn't get accessible to everyone that needed it, and that was a really big problem. So something goes down, parts of the infrastructure stop working, not good. So now we're going to talk about Redis. Why did this happen? Why was this a problem? And what does this tell us about cases where it works well, where it works poorly? So the way to think about Redis is people think of it as a key value store. That's kind of a bad way of thinking about it. We were actually using it a lot as a queue, right? So you can have these lists in Redis. You can append to one side. You can pop from the other and stuff like that. There are a lot of sort of data structure manipulation features within Redis. And those are actually really useful when you need something local, RAM-based, and if it can keep up with your current workload. Now, Redis stores everything in memory. So it basically stores everything in memory, and it is a single-threaded event loop that answers queries, manipulates memory, and returns the result. Okay? Now, people will say, wait, I've seen Redis use more than one core. This is true. There are auxiliary processes around Redis that can do things with like storage management and some, if you write Lua scripts, those will run in other threads or processes, et cetera. But the core request is just a single event loop that accesses a block of memory, okay? And this actually means that while Redis runs really fast, it doesn't scale. So, I mentioned it's a single-threaded event loop. It's very well optimized to be a single-threaded event loop, right? You don't have to worry about concurrency. You don't have to worry about latching. You get a lot of the sort of performance benefits that Stonebreaker talked about with Volt active data. But the major cost is there's no concurrency. There's no scalability. And what this means is you're actually stuck with something that runs exactly one speed. And that is the speed of one core on your system. So what does this mean? Okay, so how does persistence work in replication? This is actually kind of important. With replication in Redis is actually very similar to streaming replication in Postgres. You get binary changes that come over, they get applied to memory. Now, what this also means, if you think about it, is that each of those writes that gets replicated is also competing for time in that single-threaded event loop, right? So it's not like Postgres where you have a wall replay process. In fact, this is then going into the same request pool. And this means that high write workloads like we had are actually really problematic from a Redis scaling perspective. Persistence in Redis is completely optional. You don't actually have to write anything to disk. Great if you don't want to. If you actually care about data persistence, then you'll typically have a snapshot, and then you'll have these append-only files, and you'll have another process that will come through, and it will basically compact things in. That's why some people will see Redis taking more than one core, usually. But changes are made in memory first, unlike the write-ahead log where they're made to the wall first, right? So what does this mean from a performance and scalability perspective? I've already mentioned no parallelism, okay? So if you need parallelism, what do? You set up multiple Redis instances on the same system, one per core, right? Each of those Redis instances now needs its own block of memory, so you have to throw more memory in the machine. This is somewhat expensive, but you can kind of tune it to the point where if this is what you want, it will work for you, right? Again, as I mentioned, each write competes with reads, and if you're replicating, then that means that you're replicating all the writes. So if you have a case where your writes are maybe saturating 50% of that event loop, then every replica you add can only basically contribute 50% of a core to being able to serve reads. Okay? Now, it's extremely fast for one core. It is extremely difficult to scale up, right? And so what typically happens is that people start using Redis because it looks fast, and then at a certain scale, they realize it just doesn't get any faster, right? Some workloads really don't work well with persistence. So if you have queues, for example, you're writing to a list, you're popping off. Every time you write, you're going to persist the copy of the list to disk, the whole copy. There's no incremental update to these data structures. So how do people solve these solutions? And this is actually how you get to this massive, complicated piece here. First thing is that you can shard your Redis instance, right? You can have multiple different pieces of the data set on different instances. Each of those instances has its own memory, its own core, and that's fine. And then you use something like Nutcracker. It's Twitter's proxying, sharding proxy. And basically that will allow you to route certain key requests to the appropriate shards. Now, doing HA typically means that you have to do it with another Redis instance called Sentinel. Sentinel is a Redis instance that is then used to effectively manage other Redis instances and which one is leader and follower. And that can cause some issues. If you don't have it set up completely right, you can end up with split-brained. You can end up with a lot of difficulties. But set it up right, and it works reasonably well. But the big thing here is that because of the architecture, you're facing these problems in Redis much earlier than you are in almost any other database system out there, right? Basically, as soon as you've saturated one core, you're having to tackle sharding. Right? Very few other databases force you to do that. So, I assume everybody here knows what Postgres is, right? Big thing is, it's an extremely flexible, very sophisticated relational database management system, sometimes called an object relational database management system. Not going to get into the distinction on this talk. It's not really relevant since we're just talking about internals. But as Postgres new versions come along, a lot of the bottlenecks that are involved in scaling up to more cores tend to get removed, right? And so Postgres actually scales up to a very large number of cores very well. Back when 9.5 was the current version, I was working on a database system that used 48 cores effectively and ran with 3 terabytes of memory. It was an expensive server, but it was also managing a 12 terabyte database. I challenge you to figure out how much more you'd pay to have 12 terabytes of RAM sitting around, right? PostgreSQL's architecture, every backend process is single-threaded, but each request is handled by a parallel backend process, right? So you have multiple backends, they're each doing things, they're communicating to each other with disk or with shared memory, they're doing things on disk. It'd be kind of nice if like multi-threaded extensions would be possible in a backend, but it's actually very nice that you don't have the possibility of one request trampling on another request's memory. So Postgres is really built to scale up. And this is the big difference between Postgres and Redis. Redis is small and fast. Postgres scales up, right? And this is the big difference that you kind of have to start to think about. So in Postgres, as I mentioned, transactions are persistent by default. I'm not going to go into all of the reasons why I said by default. It is possible to really mess that over. You can, of course, use onlog tables, or you could turn off fsync, or there are other things that you could do that would make transactions relatively non-persistent, right? But by default, unless you start like removing the safeties, transactions are persistent by the time the application is told this is committed, it is persisted to disk on at least one instance, right? Now, replication is also tied to persistence. So the same mechanisms that we use to persist data and make sure that we're confident the data is persisted are also the same mechanisms that we use for replication, right? So you don't have any possibility of making a change and then that change not getting replicated. So in this regard, it's also probably a little more robust than Redis is on the replication side. There's also a lot more options in replication, and this actually becomes important in the solution we did, which was we used logical replication for a lot of things in Postgres that we were using Redis replication for in Redis. So you have logical replication, you have streaming replication, you have some things like, I mean, I've still used Bocardo in some projects due to the fact that you can put some interesting transforms in place and stuff like that. So now let's start comparing these together and talk about like why people think one is better than the other and sort of how this, how to make a decision. So Postgres, first of all, is significantly slower on a single core, right? And the reason for this is that you have all this concurrency stuff that has to be managed, and you know, that imposes a pretty significant performance penalty on Postgres taking a single query, executing it, and returning a result. You also have the fact that you have latency from disk and so forth like that. They're just built differently, and they are they're built, frankly, for very different workloads. So Postgres on a single core will never be as fast as Redis. That's fine. The thing is that Postgres scales to multiple cores, and Redis simply doesn't. And so, you know, if you have 20, 30, you know, cores and they're actually doing something, you're never going to get that kind of performance out of Redis. You won't. At least not without a massive amount of complexity. So at massive scales, like the big problem that people actually face with Postgres in this regard is that there's not a lot of tooling for doing distributed data in Postgres. So typically, if you're doing a lot of distributed data, you're either rolling your own solutions or you're sticking with something that somebody's built for some particular purpose and it's not actually applying to your workload. So that's actually a big challenge, and it means that you have to have good people who know what they're doing. It's not necessarily a reason to say Redis or Postgres is worse than Redis, but it is a cost you need to be aware of going into the decision. Right? So once you actually have to start saying, this database isn't fitting on one machine anymore, now you probably want experts in your company actually figuring out how to do it. But the difference is Redis has all this tooling because people hit it really early, right? And then by the time you'd hit it in Postgres, if you're trying to do the same thing in Redis, you already have this Baroque, complicated architecture that you're going to have a lot of trouble maintaining and a lot of trouble managing. So finally, I'd say at any kind of scale, Postgres is usually less expensive than Redis. RAM is more expensive than disk. Even expensive disks are not as expensive as RAM. And you don't have all of this complexity over sharding things very early. So this was the one that I discussed. This slide is misplaced. I'm sorry about that. I will just move on. So I want to make sure that I still have some time for questions. So we'll go through a few different areas where one side is better than the other or different patterns that people use. And I'll talk very briefly about what we actually did with this big Redis instance, and then I'll take some questions. So one pattern that people often use is Redis as a cache. In other words, you start with everything writes to Postgres, and then maybe you find some way of writing the changes to Redis also, and then you hit Redis with reads. As long as your data set isn't changing very frequently, that actually works really well. I didn't get it in the slides, but somebody today introduced me to a project already that will pull logical replication data and feed it into Redis. This prevents the cache invalidation problems. So there are ways of solving these problems, but again, the biggest issue is this works best if your data is actually not changing very well, because if it's changing frequently, then the question is why you even have a cache. Going the other way, you can do what we did, which is to basically use Postgres as a key value store. There are, in this case, what you do is instead of putting Redis out there to handle certain queries, you just simply say, Postgres is doing the things that Redis was doing. And the basic thing you do here is you find some sort of a semi-structured data format, and you put your data in there, right? In our case, we use JSONB. JSONB, of course, isn't the only thing you could use. HStore is still around. You could even, do one key, one value in a table, right? Key value lookups still work. But it really depends upon your use case, and you have to sit down and thinking about that. Now, this works very well when you're just using Redis as a key value store. It does not work very well if you're trying to replace Redis as a queue, because then every addition to the queue, every deletion of the queue is going to have the same problem you have in Redis, which is you're copying the next state of the queue to the next row, right? Otherwise, you'll have some problems there. So on to the conclusions. And I think before I do this, I'm just going to simply say what we did in this case. What we did was we took all the configuration data that was being queried in Redis. We just simply moved it to a Postgres database, and then we used logical replication to distribute it everywhere so that, if you have 700,000 requests a second, which is what we had, that they can all hit a Postgres instance close to them. Yeah, there will be a little more latency, but at 700,000 requests a second, throughput matters much more than latency, right? So that's what we did. It actually worked really well. So going then back to the conclusions that we can draw from this experience and from the discussions of the internals, Redis and Postgres are just different, right? You can't look at them and go, oh, one's fast, one's slow. You have to look at them and you have to say, you know, this is how this works inside, and I can make it do what I need it to do for this particular use case. Or, no, I can't make it do what I need it to do for this particular use case without a lot of headaches. Redis is a good choice if you have a small data set that's mostly read-only. So actually a really good example would be one place where I did some consulting for a couple of years. We were using Redis for distributing all of the authentication tokens geographically, because people would come into one website and then they would effectively have to do something on another website in another country. And so we would use Redis to distribute just the authentication tokens. It's a small data set and it doesn't change very often, right? You can handle all the expirations with just Redis time to live, and great, worked great. On the other hand, you know, with the adjust workload, it didn't work very well because for a long time that was a very heavy write-oriented workload, and you just couldn't get Redis to keep up. What I would say is that, like at scale, Postgres can replace Redis on many workloads, not all of them, but many workloads. And this is something which should be considered when you're actually trying to decide sort of which database system that you in fact want to use. And so cost, when you think about how much is this actually going to cost to implement, it depends on a lot of factors. You can't just simply say Redis is cheaper or Postgres is cheaper. You actually have to look at the data set, you have to look at the internals, and you have to try to match how this is working and how you're building a solution based on the internals if you're operating at scale. So as I say, I would typically recommend Redis today in cases where somebody has a small read-only or read-mostly workload, especially where that time-to-live feature helps you out. The problem is that larger data sets are going to give you cost problems, they're going to give you sharding problems, and write-heavy data sets are going to give you scalability problems. So that kind of ties Redis into a smaller set of problems than people are typically thinking about, but those problems are still cases where you know, Postgres probably will never compete, and you know, that's frankly fine. So I mentioned the case of distributing authentication tokens. That's actually a really good example for something where Redis would beat Postgres in almost every case. On the other hand, if you have a high velocity data set, the higher the velocity your data is, the more problems you're going to have with Redis, okay? The larger your data set, the more problems you're going to have with Redis, at least as far as cost and memory based, right? And so if you have like something where you're writing as often as you're reading, maybe not a good idea to use Redis there under almost any circumstances, because as soon as you outgrow it, it's going to be extremely painful. On the other hand, you know, if it's a small thing, it's never going to get very big, and it is, you know, something where your only writes are like time to live. Why not? So, I'd like to take questions now, if there are any. Go ahead. Hello?
Okay, so when you said, you know, the Postgres and distributed data and you had to take effort, right? So looks like you use the logical replication to scale out from Postgres. So If it was like, the sharding was the available option with Postgres, would that have helped? Or?
If there were sharding, okay, so one of the other difficulties with sharding that we don't like to talk about is that there are many different strategies, and those strategies have different trade-offs, especially when you want to do things like joins, right? Yeah. So at Adjust, we were doing all of these sharding stuff, but we were doing it all ourselves.
Yeah, yeah.
It would have been a lot easier if these things existed, but because they didn't, we built something that was tailored to our workload,
Okay.
and that was something that we were able to do.
And just to get the idea, beyond how many nodes you thought that, it's a overhead, administrative overhead with Redis?
On Redis or on Postgres?
Redis.
Okay, so on Redis, when we finally got rid of the Redis cluster, we had, I think, 20 servers each with 10 Redis instances on them. So that's like 200 Redis instances. Yeah.
Thanks.
Hello. If I have a read-only table in Postgres and data fits in shared buffer, right?
Mm-hmm.
And if you have a connection pool so that you don't create a lot of connections, right?
Mm-hmm.
So in that scenario, what is the performance gain of Redshift compared to this Postgres?
So Redis, okay, so again, the thing is that because Redis is a single threaded event loop, what you see is that there's no concern about concurrency. So there are no lightweight locks.
Right.
There's no pinning of buffer pages. You don't have to worry about moving something from one NUMA domain to another. And so a lot of problems that you can run into performance-wise with Postgres don't exist with Redis because Redis can't deal with the kinds of scale issues that Postgres has to. So yeah, even in those cases, I would expect Redis to be much, much faster than Postgres.
So this is mainly because of the reduced lock contention.
Yeah.
Yeah, I think we have been having silo comparisons, right? So I just wanted to know your opinion on like side-by-side existence of these two technologies, right? Where they probably give much more advantage over any other one, right? Your perspective on that.
Yeah. So for side-by-side usages of Postgres and Redis, there are sort of two main scenarios where I've seen it work okay. The first is where you have a data set where some data gets like read frequently in a short period of time, and then maybe gets cold again, and so something like a cache can work really, really well. The second case where I've seen it really work is where you have a separate data set that is sort of secondary to what you have in your Postgres system, where the data set is small, maybe the values are temporary, your only real queries can then be used to set the time to live and see whether the key exists. And so in those particular cases where you have either a data set that fits really well into Redis's workload, or you have like a caching scenario, those are the two cases where I see side-by-side coexistence being very helpful. There may be others, but those are the ones I've seen.
Have you seen any enterprise-level applications using this way together?
Yes,
Any
I have.
examples?
I did some consulting at one point on a medical studies tracking system that was using both. That was actually another case where eventually we did remove Redis because the combination was causing more problems than it was solving.
Thank you.
So as you mentioned that people are using Redis for keeping their memory in, keeping their data in memory, and let's say they do not want high consistency, high durability, because although it provides write-ahead log based like Postgres stuff, but people have come up also single thread that you mentioned, and people have also come up with alternatives like Aerospike you mentioned, right? So what are your thoughts on like Redis or Aerospike? Which one to use? Let's say so.
So,
or maybe you have tinkered with any other open source in-memory data grid management solutions.
So one thing is, Aerospike is actually not in memory, and this was one reason why they were shifting some things to it. Aerospike stores the data on flash storage, and it has a flash optimized storage for that. But then by default, the indexes are in memory. So finding the data is typically in memory, but the data is on disk. And if you restart Redis, you restart Aerospike, in that configuration, it reads through all the data and rebuilds the indexes, and then it's ready to answer queries again. Aerospike right now is an alternative to Redis at scale. And it scales reasonably well. If you push it too hard, if you push Aerospike too hard, you can run into very, very difficult to deal with problems. But I think you run into that with almost any very high velocity system. But the thing is that like Aerospike's enterprise offering is not open source. They have a community offering that's based on a very old version. And I don't have a massive amount of experience with that version. So I would say, it is definitely something worth evaluating. But at least like one of the things that we were looking at, that I actually did a study on, was how much would it be more expensive or less expensive to just move everything from Aerospike into Postgres? And it, at least from my perspective, looked to be less expensive to put it in Postgres. So that's, that may be me being pretty biased, but it also could be me knowing Postgres better and how to optimize it than I did Aerospike. So.
Any other questions?
Do a time check. Right. No other questions? Right, thanks. Thank you.